let's get into the big topic of open source, something that we actually say at Red Hat.
We have a
This is so
we
awesome.
are an open culture that believes
actually
in
a big
employee
piece
What is that process that a developer, or let's say a
As the
developer-
Kubernetes ecosystem really boomed,
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am Andrew Sullivan, joined as always by the amazing Jonny Rickard. How are you today, sir?
I'm good, dude. How are you?
I'm doing pretty good. I'm, it's mid-July here in the northern hemisphere, which means that it is uncomfortably and unbearably hot and humid in the Raleigh area. So it's, I'm living life.
Yeah, we just got some rain from. We got the delayed hurricane from Beryl, so it was supposed to hit us like day before yesterday, but ended up like I guess it just waited another day, took a snooze, and then ended up we got a downpour yesterday, which is very nice because it was like 105, and now it's like 75, so it's pretty nice.
Yeah. Well, I have gotten 1 day of rain in the last month, so this is amazing because it means that I don't have to mow the grass.
Yes. Yeah.
So
Yeah. And Texas is just dirt at this point, so
yeah, it all works out. So welcome to our audience. We appreciate you joining us today. Today, we are joined by a couple of folks from IBM, and we're going to be talking about IBM Fusion, which I have learned is no longer has Spectrum in the name. But importantly, this is also an appliance, and I know one of the really cool things that y'all are going to be talking about is using IBM Fusion and hosted control planes to create sort of a scalable method for deploying OpenShift clusters. So this one's interesting to me, right? We get a lot of questions about hosted control planes, not just here on the stream, but sort of in general. And I think seeing a real world example and application of how this is not only done, but why it's done, why it's useful, I think it's going to be interesting. So I will ask you all to introduce yourselves. And I'm now realizing that your names are not turned on. There we go.
Hey.
Now we can see who we are.
Cool,
so
yeah.
Lisa, Lisa, I'll ask you to start.
Hi, I'm Lisa Houston. I'm with IBM Fusion, and we've been working on hosted control planes for a while now. And we're going to discuss that as well as we created an open cluster management add-on to help deploy our services. So we'll talk about that too. And that's Ben, the great Ben.
Yeah. Hey, I'm Ben Randall. I'm a development architect with IBM Fusion. Really excited to talk about hosted control plane. When we first heard the concept, it was like, oh my gosh, what can we do with it? I think the first time it was explained to me, I was like, that sounds kind of interesting. And then it clicked. This like OpenShift on demand that we could do with an appliance form factor. So cool to show you what we got.
Yeah. Yeah. Not to mention, just the whole concept of hosted control planes where the control plane is just another workload. We already have some place to host it. It doesn't matter if it's a dedicated host or shared host. It was kind of, to your point, kind of mind blowing once I realized like, oh no, this actually makes a lot of sense. This is really cool.
Yeah, we had Adele on, right? And he came on and he was talking about it. And you and I had been talking about it for a while. Like when it started, like the notion of it came out, and we're like, sounds cool. And then Adele came on and he was just like, this is what it is. Where I go, like, it's crazy. And we use it all the time. My team uses it daily. Like it's pretty incredible. So I'm a big fan.
Yeah. Yeah. I know you all use it regularly. I think we even have, so for Red Hat folks, certainly on the product and engineering side, we have a thing called ClusterBot in Slack. I'm pretty sure ClusterBot uses hosted control planes now.
Okay.
So you can just go into Slack and, /bot and order up a whole new cluster and have it within a few minutes, which is really cool. All right, I'm still in the process of rearranging Windows and getting all my stuff in order here. So let's see. First of all, to our audience, again, thank you for joining us. This is an office hours live stream here on Red Hat Live Streaming, which means that we are here to answer sort of any and all questions you have about OpenShift. So if there's something on your mind, challenges you've been having, questions you have about how to get started or anything like that, feel free to ask those as we go through. Whatever platform you're on, when you chat with us, it will go out and it will go across all the other platforms as well as up to us. So don't be afraid to reach out. If we don't know the answer, and let's face it, Jonny and I are mediocre at best at these things. So we don't always have answers. If we don't have an answer, we will do our best to try and find the answer here in the background while other things are going on, because we can reach out through Slack and email, etc. If we can't get an answer today during the stream, then we'll just follow up in one of the future ones. Or even we have a non-insignificant number of times where we spawned blog posts and other things from folks from the questions that you all ask. So keep an eye on the, what is it now? I think it's redhat.com/blog. And then there's a hybrid platform or hybrid cloud category. Yeah, it's changed over the last, it's changed a bunch of times because we keep re-platforming.
Oh, Andrew, your audio looks like it's dropping out a little bit. It was solid, and then it just kind of dipped there for a second.
I blame solar flares.
I do too.
I'll move that closer. Hopefully that'll help.
Yeah, it's better.
I'll quit moving around and turning my face, because
you're like the happy parrot, like just kind
of. You know what I just realized as I'm looking at my settings over here? I had adjusted it because I was doing a bunch of video recordings for the learning services folks. And so nobody can see this. I don't know if you can tell. So I have a different camera, and now there's a light up here, and I have a light that sits up here. This one isn't turned on right now. And then I have a green screen that's not up right now because I had I'll show you sometime, Johnny. I have this, my office was turned into a dark cave with artificial lighting so that I could, look like I know what I'm doing when I'm creating videos for the learning services folks.
Nice.
Yes.
Anyways, what was I saying? I don't even remember now. Brain, no worky. Anyways, so please join us. If you're watching us and we don't have an answer for you today, we'll follow up next week or even a blog post. I will also point out, I know a lot of folks don't watch us live, so you are more than welcome to reach out to Johnny or I. If you're looking at your screen, you can see our email addresses there. For me, it's going to be Sully, Sully at redhat.com, or Jonny, Jonny at redhat.com. Feel free to reach out to us anytime. We love to get emails from y'all. We do our best to find those answers to get back to you. A lot of times, it always seems like we get the hardest questions in email, which I kind of like because it means that we can just directly reach out and include the smarts, product management and engineering folks. And it doesn't mean we have to we have to tap dance. But please don't hesitate to reach out to us anytime. Hello, Jerome. Question: I'm a current RHCSA and looking to pursue my RHCE. Congrats! It's a not an insignificant accomplishment. But please feel free to ask your question. We'll address it as it comes up. How hard is the exam? I feel like that's a loaded question. I don't know, Johnny.
It's hard. It's hard.
Yeah, you've taken it more recently than I have.
Yeah, I mean, they're all, as far as I'm concerned, they're all hard, but this one is particularly hard because it's Ansible. And even though Ansible is pretty simple, the way that the questions that you get asked are probably some things that you wouldn't normally do. So, it's just one of those things where you have to study and know how to look up the things that you're trying to do, right? So Ansible doc and use the existing documentation that they provide. So, the hardest part is the time constraint. If given any amount of time, you could figure it out, but the 2.5 hours or whatever it is, 3 hours, it's a crunch when you're stressed.
Yeah, that was the big one for me. You don't have to know everything. I don't think it's reasonable to even think you could possibly know everything, but it's one of those you should know 80% of it well enough to be able to accomplish, and then there's 20% where you're going to be like, crap, I don't know. But you have the documentation available. So if you know where to go and look, or at least where to start in the documentation, then you have a pretty reasonable chance.
Yeah, I think with this too is if you review the exam objectives, if you're looking at them and you can say, okay, I'm comfortable with that topic, or I'm comfortable with that concept of doing that thing, then you've got you should understand that I'm pretty much ready to go. I'm as ready as I'm going to be. If I can look at the topic and say I'm good, then I'm ready to move on.
Yeah. The first time I took it, it was Looks, the encrypted file system for Linux.
Yes.
It's there's no way they're going to ask me anything about that. I'm not even going to bother to learn any more than the very basics about it. And sure enough, it was
they
create an encrypted drive and mount it at boot time and this and that. And I'm going to get through all of these other things and then go back and look up that one. Yeah. So anyways, Yeah, good luck. I know there's a bunch of self-study guides, as well as I cannot recommend the Global Learning folks. I know they have a bunch of like exam prep courses and stuff like that. So definitely use those resources. Yeah, Jamie, thank you for the book reference there, or recommendation rather. Top of mind topics, Johnny. What have we got today?
All right, so not a whole lot, just because we're really just kind of catching up from, we had some streams, we were going to do some streams, and then we had some people cancel, and then holidays, and life. But yeah, so OpenShift 4.16 to what's new dropped at the end of June last month, and so let me grab you the link here. So if you want to catch up on what's going on with 4.16 and what's coming out, check out the video. It was really well done. Probably the best produced video of all time, in my humble opinion, mainly because I was the one that streamed it out. So yeah, and they caught me like doing the countdown in the very beginning, which is funny. Yeah, so check it out. It's actually a lot of great information coming out, a lot of cool things coming out with the product. And then one thing I can't believe we forgot to do on our last stream, but it's super important, is that Kubernetes turned 10 June 6th. So happy birthday, happy belated birthday, Kubernetes. Yeah, really awesome. So I can't believe I forgot that. And yeah, no, I'm just trying to make up for it now.
Well, OpenShift 4 turns 5, I think, next week.
I know. It's crazy.
We've got OpenShift Week for any Red Hatters. OpenShift Week is next week inside of Red Hat. So apparently, if you're in the Raleigh area, there's going to be cake. So I don't know. I'll be on PTO. So unfortunately, I will miss the cake.
Oh,
yeah. Yeah, so 4.16. So 4.16 is out the door. You can go and download it. You can deploy new clusters. So remember that stable updates are not yet available, or updates are not available in the stable channel, I should say. However, the fast channel is available. So as always, it is fully supported. You can go and update today. If you encounter any issues, you can always pick up the phone and call us. I know the release management folks make a big deal. And who did we have? Was it Subin? I think Subin was on talking about how like there's no difference between fast and stable. Like we should all just be using fast. But at the same time, I get a lot of folks don't feel comfortable with that. So
yeah,
if you have non-production or production clusters that you feel comfortable, please use fast. We definitely appreciate that, and let us know if there's any problems. You will also see a bunch of noise starting next week on the hybrid cloud blog around OpenShift 4.16 features and stuff like that. So just a little bit of background insider information. We decouple the release from the launch. So the release happened back in late June, but then the marketing folks don't do the launch until usually a couple of weeks after. Or if we're close to a major event, they'll coordinate it with a major event like a KubeCon or a summit. So anyways, that's why you're seeing like a 2-week or 2.5 week lag time between us making a bunch of noise about it and us actually releasing the So I have 2 things for top of mind today. So one is, and I had a meeting with the OpenShift documentation content strategist a couple of weeks ago, which was a fascinating meeting. And one of the things I learned is that we have completely redone the docs portal for Red Hat. So I don't know if you've seen this yet, but there's now a docs.redhat.com. So if
fancy.
Let me share this. So this is docs.redhat.com, and it is a completely redesigned portal. There's a ton of stuff inside of here. We can click on, view documentation. It has all of these, different sections here, right? If I want to go to install and installing, I have here, I want to install onto Nutanix. Well, here's exactly where I need to go in order to get that information. So, I've been using docs.openshift.com for ages and ages and ages, but I have to say, I really appreciate this interface. I like the organization. I like that I can choose the format from right inside of here. If I want to download this as a PDF, I have it available, all 3,613 pages of installation documentation.
Oh, yeah.
I feel like I shouldn't call that out. I feel like that's not.
You're just being mean.
So, but yeah, it's docs.redhat.com. This is the new landing place for not just OpenShift documentation, but all Red Hat documentation. So definitely, I would say start migrating your docs links and stuff like that over. At some point, I'm told that they will have the logic in place so that all of the documentation will redirect. So if you're going to docs.openshift today, it'll redirect automatically over to docs.red hat. Let's see. OpenShift is new to me. I'm just reading your question here, Jerome. Know about it, but don't use it at work. Yep. OpenShift is so the 5-second version of OpenShift is Red Hat's Kubernetes distribution. So, kind of taking Kubernetes, which is a scheduling engine for lack of or to oversimplify things, and wrapping it with all the things you need to do to deploy enterprise applications to production. White Star, I'd like to know about OVs. Oh,
he's talking about open virtualization.
OpenShift virtualization. It can run VMs in OpenShift. Is there any additional functionality to KubeVirt used in Kubernetes? Yes. So the biggest one is there's a wonderfully beautiful GUI associated with it. From a feature standpoint, KubeVirt is upstream, so there's a few more things inside of there. The big one being VM pools that comes to mind that aren't supported with OpenShift virtualization. But aside from that, you also have sort of all of the things in OpenShift that make OpenShift, well, OpenShift. So think bare metal management and how I deploy clusters inside of there, utilizing things like node and machine health checks and the remediation, node remediation / fencing operator in order to do things like high availability. So one of my nodes has fallen through the floor and I don't know how to, or I need to recover that workload as quickly as possible, right? OpenShift provides additional agents and features and capabilities for that beyond just what's in KubeVirt. So, Jonny, we should really add OpenShift virtualization as a topic again. I feel like
I agree.
It's popular. Yeah.
Especially now, like it's really coming up quite a bit, like almost, if not weekly, close to weekly.
Yeah. Let's see. The other one that I had here that I'm just going to show it briefly and then move on, is image-based installations for single node OpenShift. So I will paste this link into the chat here. So single node open or image-based installations for single node OpenShift it's really targeted at edge use cases where I have a large number of very small, single node deployments. And I want to be able to, in my main site or in my main data center, I basically either pre-install or I generate an ISO to install onto those single node instances. And then I ship them out the door and they go out to the site and I power them on and I do the last little bit of customization, whatever the site IP address scheme is, DNS scheme, etc. And then I have my cluster up and running. So as opposed to the, I have to take the ISO with me and I boot the ISO and then I go through and I have to download all of the different packages and all the different container images and blah, 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 blah. The goal is to have this installation process dramatically simplified for those edge use cases.
It's like the factory side of it, right? Like just you spin everything up in the factory and then deploy out to the edge. Pretty nice. Yeah.
So definitely, if that's something that's interesting you, take a look at it. See if it's see if it can meet your needs. I don't know if you can see the little bar up here in the corner. It's a very lengthy article and it goes into a lot of detail about how to set everything up and what the requirements are and limitations, etc. So it's a good one. Let's see. Was there any others that we had? Did you have another one, Jonny?
Yeah, the last one is the State of Kubernetes report came out mid-June. This is the link. And the biggest finding, the only reason I'm bringing this up is because we've had so many conversations around like product security and then DevSecOps and stuff like that. But like one of the findings that came out was that DevSecOps practices are common across more organizations now. So 42% of the respondents reporting that DevSecOps initiatives are in an advanced stage, which is pretty incredible considering where we were 5 years ago, right? Like DevSecOps was probably like a what? Dev what? Like people were just coming around with DevOps. Yeah, exactly.
DevOps. There's no security.
Exactly. So to see that evolution, like we always talk about the growth, of the technology as we keep going along. Like it's pretty cool to see that like now some of these big corporations that we're talking to, right? Like it's part of their DNA now, and so hopefully there's less leaks. So and that's it. I just wanted to put that out there because I thought that was pretty interesting.
Awesome. Thank you. So Lisa, Ben, let's talk about IBM Fusion. And I'll admit, so I have some ancillary familiarity, and by that I mean I've led a couple of training courses and stuff like that with the Fusion folks around OpenShift virtualization and things like that. But I am, mea culpa. I'm not familiar with details, so I kind of want to ask you, like, I don't know, I guess start at the beginning. What is
Sure.
IBM Fusion, and then I definitely want to hear about hosted control planes.
Okay.
Yeah, so Fusion's available in a couple of flavors. Where we started out in 2021 was releasing basically an appliance version of OpenShift. So it's basically OpenShift in a box. I have all my bare metal, nodes for control for workers. I have GPU nodes. I have switches both for the OpenShift network, storage network, and managing all the hardware. And we have storage, in the appliance. And so you basically run through our installer and you get a running OpenShift cluster. This isn't something where we just give you infrastructure and you go figure out how to install OpenShift on it. It's basically OpenShift in an appliance form factor. And beyond that, we also support running wherever OpenShift runs. And you say, well, how does that work if you're an appliance? Well, we're not only an appliance, right? We're also a software stack, right? So you can think on top of this appliance, we run a series of operators that provide data services. We have Data Foundation, which provides block, file, and object storage. Key to OpenShift virtualization, it does RWX block, right?
Yep.
And of course, that can run whether you're running OpenShift, in the public cloud on, say, Amazon or Azure, running on, Z or Power, or, bare metal. We also have data services for backup and restore, right? So backing up a containerized applications, not like doing like an old legacy app where you just kind of have this one thing that you're going to back up. But now I have 20 different microservices. They all have different, considerations for consistency. How do you back that up and restore it so it actually comes up and running, quickly and cleanly? We have data services for disaster recovery, things along those lines.
And was that the group that had one of the first dynamic plugins to the OpenShift console, or am I thinking of the HCI folks?
Yes, that's right. So our Data Foundation storage has a dynamic plugin. It'll show up right under that storage menu. And so along with your storage classes, you can also monitor the pool of storage. We've since expanded that out for backup and restore as well.
Yeah, that's really cool. I can't advocate for that enough. Of like directly within your OpenShift admin interface, you can go in, you can see the health and capacity and all the other things about your storage system as well. It's not separate. It's not disparate. It's in the same interface.
And you can even do it in ACM as well, which is like the real magic, right? So for disaster recovery, you go into ACM, you say, I want to move this app from this cluster to this cluster. So you have regional DR going on underneath the covers. It literally redeploys the apps, right? And so that's kind of the magic of GitOps is, well, it's one thing to move the data, but now I need to redeploy the application, right? That kind of affects my RTO, which is how long it takes to recover. But then we have to recreate the persistent volume. So you bind to your data. And that can all be done through an ACM workflow, which is pretty slick. Yeah.
No, I think you might still be the only ones that are using ACM in that way, as basically that central, a abstracted and centralized application deployment mechanism to provide disaster recovery, which is kind of awesome.
And Lisa's going to show you us taking that a little bit further with how we do like this multi-cluster management too.
Well, now I'm even more excited.
Yeah.
Yeah. So where hosted control plane comes into the whole thing, I think it's kind of in a couple of different ways, right? So we have this appliance that gives you an OpenShift cluster. That's taking up a floor tile. If you know anything about data centers, that's kind of like an expensive resource, right? I have cooling, I have power and stuff like that for it. And I'm doing it with this rack of resources and I get a single OpenShift cluster. And it's like, how could we get multiple OpenShift clusters out of this one appliance? We hear about this hosted control plane feature, and on the surface, it sounds kind of bland. It's like, okay, well, I can run my control planes as, just another workload. And like I was saying earlier, I heard that and I was like, that sounds cool. And then it's like, well, wait a minute, we can take this one rack of infrastructure and we have a base OpenShift cluster, and that's going to run the control planes for a bunch of other clusters in it. right? And so now I can take a bunch of worker nodes and using OpenShift virtualization, create a bunch of virtual clusters, and their control planes, instead of setting aside like 3 nodes, or 3 servers to host those control planes, now that kind of comes along for, free. Obviously there's some resources involved there, but now I can kind of take this rack, set up a base OpenShift cluster, which is going to host my control planes, and then use all the rest of the infrastructure to just create new clusters within 15, 20 minutes on demand.
It's amazing how liberating it actually is, right? When you start thinking about like, you go from like, okay, here's my footprint with the traditional deployment, and then you're like, you deploy a hosted control plane, and you're like, okay, holy crap, now here's my footprint. Like it is mind blowing how awesome it is, and the quickness that you can actually spin these things up and tear them down and deliver them. I'm a huge fan of hosted control planes. So
it was a game changer for our own internal development and test, right? So we run tons of OpenShift clusters, as you can imagine that we do, and our cloud costs were like real high, right? Because every single developer wants their own cluster. Every single squad wants like 3 clusters, and we have a bunch of x86 servers, right, as one does. And it was like, well, hey, we can just kind of shovel these things like coal into the fire, just start provisioning OpenShift clusters on it. And so now we have this real dynamic environment. And so on one hand, we're able to kind of productize hosted control plane with the appliance. On the other hand, for our own internal organization, like it sounds like Red Hat is doing themselves, we're able to provide people clusters on demand, right? Somebody asks that they're able to right size it. How many workers do you want? How much CPU? How much RAM for your workload? And there's your OpenShift cluster.
It's all about dogfooding, right? Like eat the stuff that you sell and make sure that it's awesome. And like that's especially for my team. Like it was something where we have 4 people, 5 people. Traditionally, we're spinning up OpenShift clusters. 3 control planes, 3 nodes, or 3 or more nodes, or whatever it is. And then moving to hosted control planes, now we have a 3-node cluster that just kind of sits off in the background somewhere. And we use that to interact with. We spin up our cluster, we do our thing, we tear it down, and it's nice. Like the whole workflow is it's pretty incredible.
Yeah, that's exactly what we've been doing in our development environment as well. Like Ben said, we had a lot of extra clusters, or we had a lot of extra servers hanging around, and we were able to just create, I think most of our development clusters, unless they're using the HCI, are now hosted control plane clusters. So,
that's awesome.
Yeah.
That's awesome.
Yeah, it's been pretty good.
And so the other trick there was, once I create a cluster, I need things in it. I need services, right? I need storage, right, for stateful applications. And so how do I, create that cluster on demand? Then somebody's got to go take some storage provider, like Data Foundation or something, and install it in the cluster. So I have storage. Maybe I need backup and restore, DR. I'm going to have to go install a bunch of resources in there. And so we're like, well, how could we automate that? And we started to kind of look at writing our own code to, kind of inject data services into the cluster. The idea was that you just label a cluster saying, hey, this one gets storage, this one gets disaster recovery, or whatever. And we would go ahead and inject that in there. And we were looking through ACM, and we noticed, hey, there's this thing called an add-on, right? And the add-on, in my experience, is used maybe more kind of in the public cloud, where you're having a cloud provider expose some of its services into that cluster, right? And it's like, well, hey, that's kind of what we're doing. We're a cloud on-prem, right? We have cluster on demand, virtual machine on demand. And we have data services we can expose. So we, called up the architects for hosted control plane and ACM, and we're like, hey, does this kind of fit? And they're like, yes, add-ons exactly the way that you do this sort of thing. And so we're able to kind of do this, kind of following the book, which was kind of cool, instead of inventing our own thing, which is always the best way to go. So the add-on is pretty sweet.
That's awesome. Yeah, I'm gonna have to look at. I can't wait to see the demo, because like it's something that I think that like our team does like automation through GitOps and stuff like that. So it sounds like it's very similar. Not quite the same thing, but yeah, a little similar. So I'm interested. I'm definitely interested.
I think now we're gonna have to build a bot like you guys have, right?
I think we have one, Ben.
Oh, okay.
I think they have a bot for our development team, but yeah. All right.
Probably.
So do you want me to start?
Yeah, let's do this.
All right.
Yeah. Sorry, complete aside. Speaking of bots, I recently learned that OpenShift Commons has an AI bot. I don't know if you've seen that, Jonny. Yeah, the OpenShift Commons Slack, if you I think it's like OpenShift Commons team is the user in the Commons Slack, and ask it a question. It uses AI with RAG in order to answer it.
That's awesome.
Cool. All right. So here's our, I think we're generally familiar. We'll start with our kind of ACM UI, right? And we've got our hosted control plane clusters here. Folks have probably seen this before. The thing that we kind of added is that when you go to create your cluster, we're going to automatically deploy our services with it. So I'll walk through that workflow real quick. Oh, I was going to first show what this is running on. And this is the HCI box that Ben was talking about. And so you can kind of see it's got like compute nodes. And that's where the storage is. So this is the storage that's going to get used when we're doing that ODF provider mode for all those hosted control plane clusters. And we've got switches and things like that. So that's kind of what all of this is going to be running on. And then in addition to that, we had on this hub cluster, and this is our HCI OpenShift, we pre-installed a few operators to get this running. So let me go to the main thing. And the major things we need were obviously ACM. We also need OpenShift virtualization. We've got some LVM storage here, and that is taking up some of those storage disks that come off of here, over here. It's taking 3 of them, and it's going to create that storage that allow these etcd pods to have high availability. And then we also have Metal LB, and that's our load balancer. So that's going to give all of our hosted control plane clusters some IPs and so forth. All right. So then when we go to create a cluster, it's your basic ACM. I'm going to create a OpenShift cluster. It's a hosted one. I pre-populated my credentials here. I'll just call this one live demo. And one of the nice things is we can choose different flavors of OpenShift. So if you have somebody who wants 4.14, we can still do 4.14. It's got 4.16 here, 4.15. This cluster itself is currently running on 4.15. But
yeah, that's a real key capability that we've seen. Yeah,
exactly. So, you know, then if development or test is down at a different level, we can just hand them that level immediately.
Yeah, we see this a lot in the field too, where you're trying to coordinate like upgrading an OpenShift cluster, and if it's kind of multi-tenant, and you have, you know, some people that aren't ready to move to, let's say 4.16, they want to stay on 4.15. You kind of have to coordinate across all these different apps. Whereas with this, we can basically right size a cluster for a specific application, and it can run whatever version of OpenShift it wants.
Yeah.
Nice.
Yeah, and do you remember, or do you know, is there a limitation on how high or low we can go between those?
There's a slight limitation on, well, it depends on what you're talking about, but for ACM, I think we need, you know, you need 210 to support 4.15, and I think we're going to need 211 to support 4.16.
Okay, I couldn't remember I couldn't remember if there was like maybe I'm thinking of hosted control planes, like it's plus or minus 2 versions or something like that. So if I'm using OpenShift 4.15 for the hosting cluster, I can only go down to 4.13 or hypothetically up to 4.17. But maybe I'm making that up.
No, that sounds about right.
Yeah, so hosted control planes actually creates a config map with like the supported versions that are in it, and yeah, it's I think it's like down to up to, but like if you look at it's all based off the MCE release for hosted control planes. So in MCE, if you're on like the latest, it'll be like 4.15, unless you get to like 4.16. But yeah, it does have a list of like the supported versions within that you can, the deployable versions.
Yeah, it's not a full Wild West, but I think for like an organization that's kind of moving up, keeping fairly current, this is a nice kind of flexible way to do that. Not everybody has to jump at once.
Agreed. Yeah, they are not all done at the same time to the same version. They can be decoupled.
Yep.
And you're not letting 4.7 still run, like proliferate in your network and stuff like that, right? Like we're making people move along, so we're getting closer to the release.
You say that there's an awful lot of 3.11 out there somewhere.
I I'm like, I had a conversation yesterday where I'm like, I'm still like suffering from some of the battle scars that were surfaced when we were talking about it. Like I bring that up. I am joking, but I know some of my old customers are probably still running 4.6 or 4.7. So in 3.11.
Well, I was gonna say in 3.11, probably a 3.11 that you installed back in your consulting days.
It's very true. It probably hasn't been updated either.
So it's your fault. That's what I'm hearing.
That's who they're going to blame eventually. Yes.
Sorry to interrupt, Lisa. Please.
Oh, no problem.
Yeah, she's
All right.
filling in the
So
board.
I'm showing you the key thing here we do. So this label is what's going to install our Fusion services. So simply adding this label at the time you create your cluster, that is what's going to notify our add-on that we want those particular services. So first we have kind of our base Fusion. I'm going to just do them all. And then we have ODF, which is going to be our storage classes and our storage. And then I'm going to even add backup to this. And so what's going to happen is I go through here and I finish out the hosted control plane. And we'll make 3 of these. And this is where, Ben was talking about that right sizing. This is where we can do all that customization of what exactly do you need. And you'll see here, it's got these extra labels. And those are the labels that are going to just kick off the install as soon as we have a hosted control plane cluster up and ready. So I'm going to go ahead and create that one.
And it's cool that you've only specified the requirements for the worker nodes, right? You didn't have to do anything for the control. That's all kind of handled automatically. And so it's really just how many workers, how much RAM, how much CPU.
Yep, exactly. So this can take a little while. So while that's going, why don't we go take a look at one I already created, which is this demo test cluster. And what we can go see on this one, and I think I brought her up over here. And so when we go in here, we'll see it already got installed with all of our Fusion services. And what that means is we now have storage classes. We automatically have storage on this cluster. So an OpenShift admin can go over in this ACM UI, create the entire cluster, and when they hand it off to somebody, it's already got all the storage they need.
And so then I can just deploy my app and it'll just bind to the storage class.
Yeah.
So can I ask about some of the plumbing?
Sure.
So you use a label on the ACM side, which is really cool. So if anybody's not familiar with ACM, the labels are sort of key to how we apply policies, right? So when the cluster joins, whether it's provisioned through ACM or whether it just has the ACM agent added, it just looks for whatever labels match the rules, and then it pushes out the configuration, in order to match that. So I think that's really cool. And it's just a beautifully simple way of, hey, as soon as you join, here's all of the things. So that's awesome. I wanted to ask about the storage. Is it because we're using OpenShift virtualization to create the worker nodes, are we using ODF in external mode?
No, we're using it in provider mode. So this is kind of part of the Fusion, right? So Fusion over here is going to have our storage. It has a bunch of storage nodes, and this is where it's getting its storage from.
Yeah, so we're basically taking all the drives that are on the storage rich nodes, and we're forming a software-defined Ceph cluster within the appliance. And then we're using a mode of data foundation. You may not be familiar with it because it's fairly new with hosted control plane. It's called provider mode. It's conceptually similar to external mode, right? With external mode data foundation, you have an external Ceph cluster, and then you have these data foundation, clients that are running in an OpenShift cluster, and they're basically using storage from that external Ceph cluster. This is conceptually similar. It's just rather than that being an external Ceph cluster, it's a data foundation, storage system that's running within that base hub cluster. And so it's basically a provider-consumer model. One of the big advantages of that is it's only that base hub data foundation cluster that is, really fully running a storage system. Mm-hmm. All these other clusters that have this client mode installed in them, they're really lightweight in terms of, memory and CPU requirements. And so this is another efficiency, and this kind of comes along with that whole hosted control plane promise, right? Not only am I saving on the tax of 3 nodes that need to run my control plane, but also when I do these data services like backup and restore and storage, I'm doing very lightweight data services within the managed cluster, and the more heavyweight data services kind of running down below in the hub.
Mm-hmm.
It's very interesting, and I have a bunch of questions around things like, if the storage exists at a higher level, does that mean that I can easily move applications between clusters?
Yes. So with our backup and restore capability, that's basically the way that we do that now. Right. Is you would basically just create a backup of an app in one cluster and restore it in another cluster. It's kind of a hub spoke model. I just choose which of my clusters I want to restore the app in. Yeah. And that's kind of cool with the hosted control plane too, because one of the things that Jonny mentioned earlier is, hey, when I'm done with my cluster, I can just delete it. Well, if you realize that there was something important in that cluster that you deleted, as long as you had a backup of that app, you could just go ahead and spin up a new cluster and just restore your application in there.
Yeah, really so I'm showing our backup where basically we had an application on our hub and we're restoring it to the new cluster. We can restore it wherever we want with that.
And it's all the same storage underneath the covers, so it's an efficient backup and restore as well. You're not duplicating the data each time.
No, we're duplicating the data.
At this point,
we're accurate.
We're looking
if
at
we're doing DR, then yes, we would use the same. Yeah. But when we're looking at a backup restore, this is actually off-site, so that if you lose your storage.
Yeah. It's not a backup if it's on the same storage system. Yeah.
Basically, yes.
Hey, I gave a presentation about that at my previous employer. Snapshots are not backups.
Exactly.
So a little bit about what's going on under the covers, Elisa, right? When you said to create that cluster, you specified the number of workers and so on. What ACM is doing, if I understand, is creating OSVs, OpenShift virtual machines, for each of the worker nodes.
Let's see if it's gotten there yet. So I did live demo. So there you can see it's at CD pods. Everything's working on our hub cluster under this project. And then if we go into the VMs, we should see the VMs are getting created. And the VMs are getting created as well. It's all under this same hub cluster, which is our Fusion HCI in this case, but it doesn't have to be. Folks can set up their own bare metal.
Yeah, this whole stack runs the same on our appliance as it does within our lab environment, or just doing it on, bare metal.
Right. Yeah, I think the cool part too is like Lisa, I think you hit on it right where you've got the storage class available now, right? You've got to do so now your services like your internal registry can run, so you can start deploying applications and things like that. If you've ever deployed bare metal and you forgot to go set up the storage, you know exactly why this sucks or why this is awesome actually. Because it's a pain when you're like, what is happening right now? And you're like, oh no. Yeah. So I think
plus,
that's
if you're the recipient, you now have to go bug the administrative. Hey, I don't have my storage. How do I get it?
Yeah, this isn't working.
So this is a nice way it's all in one. You got it. You're good to go.
Yeah, that's pretty cool.
Yeah, so it's very nifty. So, what else can we show you? So we got the VMs, we got the pods, and the add-ons. So you can see we have our add-ons, and I don't know if you want some details on how the add-ons work.
Yeah.
But we can go into those details too. All right. So if we start on our local cluster. Let me go back to local cluster. And then what we do as part of our installation is we do what's called a manager controller. And if we go look in here, this is the Fusion Manager controller. Actually, if you'll indulge me for a second, I have a PowerPoint. Let's see if we can see this real quick. And this is, okay, everybody see that one?
Yep.
This is what Open Cluster Management shows is the way to do the add-ons. And so this registration controller, agent, work agent, that's all part of ACM. And what we created in Fusion is the add-on manager and the add-on agent. And so the manager goes on our hub cluster, our Fusion HCI cluster. And then it, through manifest workers, is going to put an agent, and we have one per service, that for us goes and lays down operators that does the installation for us. Okay.
And just for anybody who isn't aware, Open Cluster Management is the upstream for ACM.
That's true. Yes.
Mm-hmm.
Yes. So walking through how this kind of works, this is getting a little technical, I know, but I like doing that. We put our label, right? We did our label. We've got a managed cluster CR. That's where you can go see the label. We created this cluster management add-on CR, okay? And we're naming it Fusion Base. This is one of the services. It then talks to that manager controller that we install as part of Fusion software. This is going to catch that, and because it has the label, it's going to know the placement. It's going to use a manifest worker. It kind of inherits from the project to do that. And it's going to tell it how to do the agent, and it's going to go put that over on this HCP cluster. So a new pod is going to start running in the Open Cluster Management Agent add-on space. That's our Fusion agent. Now it's going to go create our Fusion operator, just as if we did it from Operator Hub. And that's what starts our installation. So if we kind of look at that, we can see it. So here's our Fusion Manager controller. Again, it's on our hub. And we can even look at logs. And you can see it's found out that I've got a new cluster in here, live demo, and I need to go start installing things. So on the one we already have, we can even go take a look at those pods as well. So this is back on our HCP cluster, and you can see there's going to be a pod per Fusion service. And this is what actually installed it over here. So
I love seeing how we solve these problems, or well, how y'all solve these problems.
yeah.
The royal we.
Because it's it's an interesting thing of how do I do dynamic distributed configuration of a large number of systems,
Right.
and utilizing Kubernetes native concepts, right? A CRD and an operator paradigm, and coupling that with traditional software development paradigms, right? The agent and everything. It makes sense.
Yeah.
Yep.
You can also imagine there's some security running under the covers that's establishing a secure connection between the provider and the consumer.
Right.
So Lisa, not only do we create these add-ons, but a key piece of work that we did too is that when you go to delete that cluster, we will clean up all the artifacts that the add-ons create, right?
Yes. So one of them. Okay, who's laughing?
If you've ever deployed an operator, you know exactly why I'm laughing, because that is a damn mess. Like it's the worst when you're trying to uninstall it. So no, that's a happy laugh. Sorry.
Yeah, I always think cleanup's the part that people don't want to do. They're like, hey, we'll go create stuff, but
Yeah.
That's so true.
If you've ever been an infrastructure admin, you know exactly what I'm talking about when you go, why is it still there?
Yeah, well, one thing that struck us was, I'm creating these clusters on demand, and when I delete them, that's going to free up the CPU and RAM, of course, that those workers were using. But how about the storage, right? I'm creating all these clusters with storage classes, and people are writing storage, and then I delete the storage, and you get this concept of a storage leak. It's kind of like a memory leak, but like it's like as I keep doing this, my storage is going to get eaten up. Various other artifacts that are kind of hidden, beyond just the storage, right? But needing to make sure that we have ways in which that can be cleaned up.
That's awesome.
I mean, storage is probably the one that I think most people notice first, because you're deploying an IPI cluster, or clusters, as the case may be, with or without ACM, and you go and you deploy a bunch of things inside of there. It's creating, especially if it's IPI, it's creating PVCs, which are really VMDKs on VMware or whatever CSI volume off your storage system for things like the registry. And you just go and you deploy that or destroy that cluster after you're done with it. And then the storage guy looks at his thing and is like, where'd all these LUNs come from? What are all of these VMDKs? Can I get rid of these? What are they associated with? And so it's a legitimate problem. And I've had calls with customers where it's like, yeah, we accidentally deleted the wrong VMDK. Please help us. Help us understand which of these we can and can't keep. And yeah, it's an amazing solution. And thank you.
Yeah, so I will point out that today it's kind of under the covers when we delete everything. We make our effort in 4.16. We don't have ODF 4.16 yet. They're actually going to give you a way to do it from the UI. So that'll be nice too. So if you kind of look at this is our storage clients, right? And you can see last heartbeat, that's where they're going with here, is there's going to be a little button that says, if it's been too long ago, just clean it up for me.
That's cool.
So that's going to help with that problem as well.
Another thing we had to work through was upgrades, right? It's like it seemed like the simple concept that we could do at first, and then you keep peeling the onion and finding like more and more things to think through, right? So I create all these different OpenShift clusters, and maybe they're running different versions of OpenShift, and now we start to upgrade, right? We're going 4.15 to 4.16 and so on. Well, how about our data services, right? We have Data Foundation, we have our backup restore data services running in these clusters. And have we created a logistical nightmare where now somebody needs to go into each of these clusters and upgrade those data services? The people using those as a consumer shouldn't really care about, how those are, manifested, right? That their services provided by the platform, right? And so luckily we were able to create a way where this just kind of magically happens. I don't know, Lisa, if you want to kind of talk through how that works.
Well, we're just using the subscription and the automation at the moment, use the automatic upgrade. So that's helping us out there. We do have some thoughts in the future about how we want to do that. One of the nifty things about an add-on is you can pass things over to it through a config map. So we've got some things like maybe you don't want automatic upgrade, maybe that you don't want it the easy way. Then we're going to not block them, but it'll be a feature that they can turn on and off via the config map and say, I want a manual upgrade. I don't want you automatically upgrading this. So we have a lot of options that come in through this add-on that we can actually use and pass over to these agents that can be individualized by cluster. So that's really nice too.
So from the user perspective, I'm putting myself in the user perspective at this point, right? The consumer perspective, right? Is this something that I would go in and say, hey, I want to? It's like I put in a ticket. I want a cluster with this, this, and this, and then it just gets done for me, or is this something where, like, I guess what's the workflow? How is your workflow?
For
is it self-service?
which bits? So if you want the data services, then yes, you'd probably say, which ones do I want? We're kind of anticipating most people want storage classes. I think it's somewhat unusual that people don't want storage. But, maybe that you don't want to give up your precious storage on your HCI and you want them to use an external Ceph. That's always possible. Backup restore, we think, is probably a little more individualized. Maybe in development, you don't really need backup. So yeah, you'd probably submit a ticket that then says, OpenShift admin, give me a cluster with these things. So it could be part of your chatbot thing, right? And these are things they could easily do.
Yeah, in terms of self-service,
it can also be automated. We have scripts out there. We do have internally, we've got some scripts and pipelines that can, from the HCP command line, add these things for you. So you don't have to go via the GUI. So sorry, I talked over you, Ben.
That's ultimately where I was getting to, right? Because like that's from a GitOps perspective, is it, is it something where I can just, that's pretty cool. That's awesome.
Yep. You can do it from the command line as well via HCP.
Yeah.
Yep. So, sorry,
And Ben, oh, I'm sorry. Sorry, Lisa. Yeah, I was going to say, like, when you're talking about peeling back the onion, right? My guy here, Sully, he likes to call OpenShift a fractal, right? Where as soon as you look at it, you just never know. Like you can start down one path, and next thing you know, you're looking at 4 different things, and then those 4 things are 10 different things. Yeah, it's a never-ending rabbit hole.
Yeah.
Yeah.
I mean, the key was to think about it in terms of like cluster lifecycle management, right? You need to make sure you have that full life cycle. You create your cluster, you use it, you upgrade it multiple times, you delete it eventually, right? And making sure that we had our pieces in play for every step of that life cycle.
Yeah, I think it's interesting to also look at, as we look at the fleet of OpenShift clusters, not all of them are long-lived clusters. I think a lot of us, I'm an old virtualization administrator. I deployed vCenter once and it lived for a decade. Maybe I have a cluster inside of there, or that's also survived for that long, or clusters, and all these other things. Sometimes I'm adding and removing them as we lifecycle things. So I think it's really important to understand that, like with OpenShift, when I look at things, like I see maybe a third to a half of clusters that are really, long lived. A lot of them just churn, and it's because people are doing development things. There's a lot of, I need to deploy and test my application against multiple versions of OpenShift, or I need multiple different versions of Kubernetes, or I need, just multiple different development groups inside of my my organization, right? This team is working on a new feature and they need a cluster for the 3-week sprint that they're working on that, that type of stuff. So it's really, really interesting to see the different sort of usage patterns. And I think it's important for a lot of us who maybe think, again, old school Vert admins like me, who think, I'm not going to be creating and destroying clusters that often. Why would I need automation like this? No, Kubernetes is used differently.
Well, how did we flex back in the day as Linux admins, right? We'd show our uptime, right? We'd just go in, type uptime. Like that's been up for a year, baby. That's what you get.
Yeah, it was the old thing of, what's the standard Windows fix? Just reboot it. Whereas, Linux and Unix, you never reboot, never.
Yeah, don't you dare.
So Lisa, are you showing us that newly created cluster?
This is the newly created cluster, Mr. Live Demo. And he's already got everything installed. So we've got all our storage classes. So in the time it took to do this, it's up, it's ready. You can hand it off to anybody.
That's awesome.
That's amazing. Yeah.
Yep.
It was probably even faster than that because we've been running our mouths.
Yeah. Yeah, so this is kind of cool because I mean, you already had you already had virtual machines on demand, right? Mm-hmm. Now you have OpenShift clusters on demand. In a way, I kind of have some of those same characteristics of what I might go to a public cloud provider for, right? I need to quickly get some clusters, get some virtual machines. I can now do this in my data center on bare metal. And I can do it with the same kind of self-service, the same efficiency, same elasticity as I can get from the public cloud.
Yeah.
Yeah.
Man, that's awesome.
Does this work with multiple Fusion appliances? Like, can I have one ACM with 2 or 3 or 10 different Fusion appliances, and I deploy clusters into each one of those?
Yeah. So today we support chaining together 3 racks. And that is a limitation of time at this point. But what you can do, so that allows you to expand, the number of clusters that you can create, the number of virtual machines that you can create. But more importantly, what we advocate is deploying those 3 racks in a 3AZ fashion, right? So if you do have a data center where you do have 3 zones for power, cooling, etc. You basically deploy these 3 racks across it. When we go through our install, we allow you to say, hey, I'm doing it with this topology, and we're going to be a bit more intelligent. When we create that initial base OpenShift cluster, we're going to distribute the control nodes across those 3 AZs. As we start doing our 3-way replication for our storage, we're going to do that across the 3 AZs. We're basically applying labels, to the node so that we know where they are. And then as you provision OpenShift clusters, we work with Red Hat to make sure we're not putting all of our eggs in one basket, right? We're abiding by those zone labels, and so your control planes are being distributed across. Your workers aren't all sitting there on a single node that you take down that node and that physical bare metal node, and you just lost your entire cluster, right? Where we're trying to limit the blast radius for any single piece of infrastructure failing.
Yeah. Node pools, cluster API. It's really cool stuff. I really like. If anybody, one of the things we'll talk about when we talk about what's new in 4.16, several of the cluster API providers for not just node pools, they've always been GA, but for machine pools or machine sets rather, have started to go GA. So that's really cool. I really like seeing the stuff that's happening there.
Yeah, we call that a HA, highly available deployment, because you can lose a rack, right? And basically an entire rack of infrastructure and have this thing keep running, whether you're doing this, via an appliance or building it, yourself within your own lab, making sure you don't have that single point of failure, right? Because you don't want to lose all your clusters just because you lost, a handful of nodes, right? And so just making sure you have that highly available deployment is kind of key.
Yeah, and awesome. I think that's probably the biggest concern that I hear from folks about hosted control planes is, does that mean that I'm putting all of my eggs in one basket? And maybe if you want to think about it that way, right, you have, your cluster, your hosting cluster that has those control planes in it, but there's a lot of mechanisms to help protect that. The very basic is infrastructure resiliency. Which is funny because, again, old virtualization admin, right? I tend to start there. That's what I tend to think about. But I know for a lot of Kubernetes folks, it's like cloud native, right? When you deploy to AWS, you don't even think about what the infrastructure is underneath. At a certain scale, you just assume that there's always going to be some percentage of your infrastructure that's not available or not adequately performing, whatever the case may be. And you just architect the applications around it. Well, now we're reintroducing those things, into the Kubernetes world, and I think we're all better for it.
Yeah, you want to make sure you have a storage architecture that can withstand failures of entire nodes worth of drives. You want to make sure you have a network architecture where everything's redundantly cabled. I know I'm kind of talking about 101, but not everybody has done infrastructure before, right?
No, and admittedly, I think we're also teaching Kubernetes a little bit about that as well. It feels like a lot of the conversations I have these days are folks who want to implement that, and the connections aren't there because I'm familiar with Kubernetes, and how do I make Kubernetes do this specific dance? So yeah, I'm happy to see that we again, the royal we're all sort of blue. I say wearing my Instruct Lab shirt.
Purple. We're purple.
Yeah. So, but it's I'm happy to see that we're making that easier.
So have you guys, and this is just the nerd, right? I'm sure product people are wanting to kill me right now, but have y'all looked at Hive or anything like that for deploying some of the more, so host a control plane, you're gonna host the control plane and then deploy the workers, but have y'all looked at Hive to deploy a traditional cluster so that we have the full capability there?
You mean like a bare metal API, Jonny?
Yeah, if you wanted to do maybe even reach out to Azure or AWS or something like that, or another bare metal capability and just spin up another, but it would be more like a full-blown traditional cluster, right? Like a 3 control plane, 3 worker type of deal. Maybe it doesn't make sense. I talked to the Hive guy a month ago, and I was like, oh, that's pretty cool, because I can see where, especially from hosted control plane, where not all the services are, not all the operators are supported yet. So sometimes it would just make sense.
I'll have to think on that.
Yeah.
Ben's like, I'm out of here, dude. Hell no, we're not thinking about that.
Well, while we're asking Pi and this guy questions, what about multi-data center?
Yeah, that's it's definitely something that we're paying attention to. The ability to support this across multiple data centers. Yeah.
Awesome.
Not there yet.
Okay, well, good to know. So for our audience, I know we've just got a couple of minutes left. If you have any questions, please feel free to get those into the chat here. And as I said, sort of towards the beginning, if you're not listening to us or watching us live, please feel free to reach out to Jonny or myself. You can reach us via email, jonny@redhat.com, JONNY, or Sully, SULLY, @redhat.com. We're also over publicly on the Kubernetes Slack. So if you go to kubernetes.slack.io, or no, I'm sorry, it's slack.kubernetes.io. I'll get it right one of these days. So you can find the button there to get an invite over to the Kubernetes Slack and join over there. And there's an OpenShift users channel that has, 3,500, 4,000 of our closest friends. So it's a great way to stay in contact with not just Jonny and I, but also sort of the entire ecosystem, the entire group of community folks and all that other stuff. That is separate from the Commons folks as well. So if you're familiar with OpenShift Commons and the OpenShift community there, you can also go to it's commons.openshift.org. Too many URLs. Thank you. And there's their comments. I knew you had one of these. So there's the Commons invite link for Commons over there. So yeah, any questions that you have, please feel free to reach out. Lisa, Ben, this has been really, really interesting. Like,
Thanks.
I feel like this is the first time that I've seen like a holistic end-to-end implementation of, hosted control planes with OpenShift virtualization, with storage, and not just the hypothetical, oh, look, I can plug all these things together, but all the way down the stack. And to the point that we were just talking about of like, hey, here is the architecture to provide, highly available, highly resilient infrastructure for not just one cluster, but for however many you want to deploy inside of there and scale that out. Like you said, up to three racks. So yeah, it's amazing to me.
Yeah, that's pretty
cool.
exciting.
Yeah.
And I also appreciate that, from my perspective, again, I spend a lot of time with OpenShift virtualization these days. It's a super great way to just have a set of infrastructure for OpenShift virtualization itself. And then, if I'm creating my new OpenShift clusters, because we still, there's still a lot of use cases, even if I'm using physical OpenShift for virtual OpenShift. Well, now I have everything available to me very quickly, very easily, and resource efficiently. Same storage system. I'm not deploying new virtual machines for my control planes, right? All that other stuff. So it's a lot of new use cases are opening up here lately. There's interesting stuff.
Yeah,
And
exciting area.
I was chatting with Mark Curry. Jonny, Mark, he's been on the stream a couple of times, chatting with Mark about some of the changes that are happening with networking in OpenShift 4.17. So if you saw the What's Next presentation, he talked about some of this stuff. So it's not VRF or virtual routing and forwarding. It's UDS. And now I'm forgetting what UDS stands for, but it's 95% of the functionality of VRF. And it's like the 5% that's not there is basically unimportant because Kubernetes. And so there's just a huge amount of really cool things that are going to suddenly open up as soon as they add this in. I don't know if it's 4.17. I think it's 4.17 or maybe 4.18. But I was in the tower one day, and Red Hat Tower here in Raleigh, and we sat down for like an hour, and he whiteboarded out all of these things. And going back to your mind blown, that was me. I was flabbergasted.
I need a drink.
And going back to the, I asked about multi-data center, or even spreading across multiple appliances with something like this. Well, now we have a lot of, or now in the future, there'll be a tremendous amount of power to now we can start connecting things together across clusters in a very dynamic way. Turns out all it took us was, 18 releases and 5 years.
Yeah. Time and patience. That's all.
All right. Well, thank you, everybody. Thank you to the audience.
This has been amazing. Thank you so much for joining us.
Thank you for having us.
Anytime you would like to come back, we appreciate
I may
that.
take you up on that.
Yeah, do it, please.
All right. Thank you so much.
So I'm gonna I got to figure out this new interface. It's killing me. So Jonny, I'm gonna figure this out while you close this.
Okay. Yeah, Ben and Lisa, really thank you again for the time. I know you're busy, and it's to Andrew's point. It's cool seeing the reality versus the hypothetical, right? Like, because we always see hypothetical, like, oh, you you could do this if you do this, this, and this, but to actually see it in practice and an awesome UI actually, and honestly, like it's really cool to see, and I'm glad that you guys did it. And thank you so much for reaching out and coming on. And we'd love to have y'all back on. And Ben, again, publicly, nice flex on the shirt. So.
Yeah, thanks.
Thanks.
All right, Jill. See everybody next week.
Cool.
Right.